Welcome to qnawire.
Okay, so we're doing chapter 34, problem 17 here. And this says a speck of dirt is embedded 3.5 centimeters below the surface of a sheet of ice, which is with an index of refraction of 1.309. And we want to figure out what is its apparent depth when viewed at normal incidence. Cool. Okay, so this is the drawing here we have. So we have this line here is our interface between the air and the ice. And we know that the air index of refraction is just 1. Ice's gave us was 1.309 here. So this bottom dot here is what we're going to represent as the speck of dirt. So this is our object here. And these distances to the ice or the interface, S and S prime, are object and image distance. So how we want to first do this, set this up, is we need to know that this is a flat surface, so we know that R is infinity for the radius of curvature. Cool. So we also need to figure out what is the quantity we're trying to find out. We're trying to find out this magnitude of S prime, because this is what the apparent depth is. So this is the apparent depth, because this is what the depth looks like from the observer. So now we need to figure out how to relate these together, and we can use our Lenz's equation with indexes of refraction, and we know that that's going to be given as the first index of refraction over the object distance plus the second over the image. Oops, I'm going to call that S prime actually. And this equals the difference in index of refractions over R. Okay, so we already know what R is going to infinity, and we know we want to find the magnitude of S prime. So we can simplify this for a little bit. If R is infinity, that means the right side of the equation is just 0. So now we can simply rearrange for S prime, and this is going to be negative in B S over in A. Cool. So that's as simple as we have to do. So let's just plug in our equation now. So we should have negative 1 times 3.5 centimeters all over 1.309. And that should give us a S prime of negative 2.67, since it's a virtual image, centimeters. So the apparent depth then is the magnitude of this, since we can't have a negative depth, and that's just 2.67 centimeters. Perfect. So what this is saying is that when the light goes from ice to air, it is bent away from the normal, and the virtual image becomes closer to the surface than the object. Awesome.